Hello and welcome to this video. In previous videos, I've taught you how to graph horizontal and vertical lines, given the equation of the line, how to graph linear equations in slope-intercept form, and how to graph linear equations by rewriting them in slope-intercept form when they're being given in standard form. This video will teach you how to graph linear equations that are being given in standard form by determining and plotting the x and y intercepts. This is a screenshot from the textbook. And notice we will be focusing on the right-hand side this time, where we use the x and y intercept method. This involves finding the x-intercept, the y-intercept, plotting those 2 points, and then graphing a line that connects those 2 points. Let's get started. As you can see here, this problem has already been worked through using the slope-intercept method. To see that work, please see the previous video that I posted. This time, we're going to do the exact same thing in that we're going to plot this equation. However, we are going to do it slightly differently. And the different way that we're going to do it is we're going to find the x-intercept, which involves setting y equal to 0 and solving for x. And then we're going to find the y-intercept, which involves setting x equal to 0 and solving for y. If you'd like more information about that, please watch a previous video where I explain in depth how to find the x and y intercepts. So let's get started. We have 3x plus 2y equals 6. So y equals 0, so that means wherever I see y, I'm going to write 0. So I have 3x plus 0 equals 6. Remember, you can also use the cover method where we literally cover up the term that contains y. Doing that, we get 3x equals 6, so we divide both sides by 3, and we find out that x equals 2. Now this is really important that you remember that the x-intercept is actually an ordered pair. It's the point 2, 0. So the x-intercept is actually the point 2, 0, which we can then plot on our graph. Now let's find the y-intercept. Again, we start with 3x plus 2y equals 6. This time, we're going to let x equal 0. So we have 0 plus 2y equals 6. Remember, alternatively, we could have used the cover method and covered up the term that contained our x variable so that we only have the y variable left. We need to divide both sides by 2. And so, our ordered pair for our y-intercept is x equals 0, y equals 3. So we have the ordered pair 0, 3, which we can then plot on our graph. So we have 2 points now, and we could, if we wanted to, go ahead and connect them with a straight line. The problem with this is that if I continue to extend this line, sometimes you get a little bit of a drift one way or the other. So to prevent that, what I like to do is I like to look at the slope between these between these points. As you can see, to get from one point to the other, you go down 3 and over 2. Let's see if we can continue that pattern to find more points on that line. Down 3 over 2, down 3 over 2. We could also go up 3, left 2, to get more points. Now that I have all these points, I can be confident that I've drawn my line in exactly the right place and that I haven't drifted to the left or the right of where the line is supposed to be. Right now, that might seem a little bit silly and like extra work, but when we get to the last section of this, or the last part of this section, we're going to be finding the intersection of 2 lines. And then it's going to become extremely important that the line is exactly precisely where it's supposed to be so that we can find where the 2 lines meet. Let's do another problem. Again, you can see that this problem has already been worked through using the slope-intercept method. This time we're going to do the same problem and graph it now using the intercept method. So remember, to find our x-intercept, we have to let y equal to 0. And to find our y-intercept, we set x equal to 0. So we have x minus 2y equals 4. This time I'm going to use the cover method right away. I'm going to cover up the term that has the y in it so that all that is left is x equals 4. So that gives us the ordered point 4, 0, which we can then graph. So let's find the y-intercept. Remember, to find the y-intercept, we let x be equal to 0 and we can use the cover method to just cover it up. Now that negative sign is still there, so be careful. We have to divide both sides not by 2, but by -2. So our final answer is y equals -2. To find the ordered pair, we need to use x equals 0, y equals -2, and then we can plot that on our graph. Again, we could go ahead and just connect these points in a straight line, but what I like to do is I like to actually find the slope. So we're going up 2 and over 4. So that's a slope of 2 over 4 or 1 over 2. So I can actually see another point right here in between that is crossing the crosshairs of the grid. So I can continue this pattern in either direction so that I have a line that doesn't drift at all from exactly where it's supposed to be. So now I have y equals, oops, I'm sorry, that's not the right equation. We'll write it in standard form, the way it was given to us. We'll write it x minus 2y equals 4. Okay, so let's look at the two graphs on the left and the right. Do they look exactly the same? They do. Now, of course, we did label them slightly differently. This equation is in slope-intercept form. This equation is in standard form, but again, the graphs themselves are identical. Let's do one more graph. This time we have 5x plus 10y equals 10. And again, we're going to find the x-intercept and the y-intercept. And then we will plot those 2 points. So we have 5x plus 10y equals 10. Okay, this time I'm going to use the covering method. I'm going to cover up the y part. So we have 5x is equal to 10. So x is equal to 2. So we have the point 2, 0. Over here, for the y-intercept, we have, again, the same equation. This time I cover up the x bit. So we have 10y is equal to 10. And so we have y is equal to 1. So we have the ordered pair 0, 1. So we have the point 2, 0, and we have the point 0, 1. Let's see if we can figure out the slope between those two lines. Well, we need to go down 1 and over 2. If we continue that stair-step pattern on either side, we can generate more points that we can then connect in a straight line. Okay, remember the last step is still important. We need to label this. 5x plus 10y equals 10. So let's look at these two graphs. Is this line the same as this line? It is. Of course, they're labeled differently because this has the slope-intercept form of the equation. This has the standard form of the equation, but the lines themselves are identical.